Quantum mechanical model. Quantum mechanical model was given by a very well-known scientist, Erwin Schrödinger. Erwin Schrödinger took into account dual behavior of de Broglie and Heisenberg uncertainty principle and put them together and gave a model which we all know and the latest model of a structure of atom, that is quantum mechanical model. He gave two basic points. He told that electron has a dual nature, that is we can we have to assume that electron is like traveling like a wave. All right, electron is a wave that came from Broglie's theory, and Heisenberg told about that we have uncertainty or probability in finding electron. We have to take it into account that we cannot predict the exact position of electron inside atom. Only we can guess the probability of finding electron in certain area of atom. So he put both these things together, that electron is a wave and we can predict probability of finding electron, not the exact position. And he gave a wave equation which we all know is popularly known as Schrodinger wave equation, that goes like this: del psi square by del x squared plus del psi square y upon del y square del psi square upon del z square plus 8 pi square m upon h square into e minus v psi equals to 0. And later there was a short form of it given like this: h cap psi equals to E psi. And h cap psi has all the variables you see over here except E. Alright, and this h cap was known as Hamiltonian operator. So this model talks about that we cannot say 100% that this will be present in this orbit or that orbit. We can say that electron is present in this region, all right, and that region was later called as orbital. Orbit was circular path in which electron is present, and orbital was the 3D space, 3D region around nucleus where electron can be present. And we cannot say it is present, we have to say probability of finding electron is maximum or minimum. And for probability prediction, we have to consider this psi is basically the wave function. Psi can have a positive value or a negative value, but you know, for prediction, we have to consider psi square. Just imagine this: if you are going from your home to your school and you see light clouds, then you say, oh, there are chances of rain. All right. If you see dark clouds, then you will say, oh, now today rain is going to happen for certain, right? So similarly, psi does not have physical importance, but psi squared do have. So if you have to predict whether electron is present or not present, where chances are high or where chances are low, we will not consider psi, we will consider psi square. Psi square is known as probability density. Psi square is known as probability density of finding electron. So if psi square is 0 equals to 0 in certain area of an atom or certain region of an atom, then we say the probability of finding electron is negligible, and we call that place or the region as node. We call that as node. If we are talking about a nodal plane, then psi square will be 0. If we are talking about a spherical surface, we will call that as radial node. Alright, and to calculate how many nodal planes are there, how many radial nodes are there, we do have formulas. If you want to calculate number of radial nodes, then use n minus L minus 1. What is n and what is L? N is number of orbit number, and L is subshell number. You put the value over there, or orbital is same as subshell. Alright. So n minus L minus 1 equals to radial nodes, and if you want to calculate number of radial nodal planes, that is equal to L. If you want to know total nodes, then add both of them. Radial nodes n minus L minus 1, nodal place L. You add both of them, you get n minus 1 equals to total nodes. So all these things you can remember for your exams, and I hope you score well. And this model again gives good explanation to hydrogen, that is a single electron atom. When we apply this model to multi electron atom, we are again disappointed because the calculations become so heavy that we do not comprehend what does that mean. So we are still stuck with the explanation of only single electron system, that is hydrogen. From the solutions of this wave equation, we could find quantum number values: principal quantum number n, azimuthal quantum number L, magnetic quantum number m, but we do not get solution for spin quantum number from this model. So first three quantum numbers are calculated from the solution of Schrodinger wave equation, but spin quantum number value is not calculated from this solution of Schrodinger wave equation. So that is what we could discuss over here. We will be elaborating on quantum numbers in further slides.